Hi everyone, welcome back to my channel. In last video we have seen about clampers, which is used to shift the entire signal above the x-axis called as positive clamper and below the x-axis which is called as negative clamper, and we have also seen its working. Now next topic is voltage multiplier. So voltage multiplier is a circuit which is used to produce the output twice, thrice or even more as we want from the given input signal. So it is just simply said to produce multiple DC voltages from a given AC signal. So this is a circuit which is used to convert alternating AC into DC. You can also call it as voltage multiplier as a circuit which is used to convert single AC signal into multiple DC voltage. So this can be done by just using one AC source and one power transformer. By using single AC source and just one power transformer, you can produce multiple voltages. So here there are three or more classifications like voltage doubler, voltage tripler, voltage quadrupler. What is this voltage doubler is that the output will be double or twice the given input. Say given input is V in, then output will be if given voltage is V in and output is V out, then output will be twice the input signal. So if it is quadruple, then it is output voltage will be thrice the given input. So quadruple means output will be 4 times the input. So like this you can produce multiple voltage level by just using single AC source and power transformer. I'll explain first voltage doubler. So as already told, we need one AC source. This is AC source where you will get an AC input signal which will be applied to power transformer. Now all we need is capacitor and diode. Since this is the application of diode, this diode will be used in voltage multiplier. So this is the circuit for voltage doubler, single AC source, and this is the power transformer. This is capacitor C1 plus minus, diode D1, capacitor C2 plus and minus, and this is diode D2. Okay, so let's I'll just tell you one thing. If current flow is from plus to minus, then let's assume it as plus. If current flow is from minus to plus, then that is minus. I'll explain this. Okay, so first let's apply positive signal. So when positive signal is applied, this will become plus, this will become minus. Say this is P and this is Q, plus minus. Okay, when this plus is applied to diode D1's anode, this diode will turn on. and when this positive is applied to cathode of diode D2, this D2 will turn off. So for positive off cycle, voltage power transformer, positive cycle, plus minus, capacitor plus minus. This diode we can represent it as closed switch, plus minus, and this diode is open switch, because here positive is applied to diode D1, so this will turn on and it will act as a closed switch, and this diode will turn off and it is acting as a open switch. So we know that KVL, that is Kirchhoff's voltage law, and let's assume that current direction is in this direction. So let's apply KVL. When you apply KVL, this is, let Vn is an input signal, so here Vn, so minus to plus, as already told, let's assume it as minus, so minus Vn. Then next is capacitor C1, that is in plus to minus, so plus Vc1. So that's all. In the entire this complete closed circuit, there are only two devices. One is power transformer, whose input voltage is Vin, and then capacitor's voltage is capacitor across Vc1, that is I have mentioned as Vc1. So here the direction of current is from minus to plus, so minus Vin, and here it is plus to minus, so plus Vc1 equal to 0. So voltage across capacitor C1 is equal to input voltage. So this is also Vc1. So voltage across this capacitor also is equal to input voltage. Now for negative off cycle, power transformer, capacitor. So when negative voltage is applied, negative, positive, okay, Vn, negative voltage is applied, so this will turn negative. Negative, positive. So this negative is applied to this diode, therefore this diode will turn off, and negative is applied to cathode of diode D2, so this diode will turn on. So now this will become open, this diode will become open, and this diode will become closed. So capacitor C1, capacitor C2, you don't have to consider this, so current flow will be in this direction, just assume. So again let's apply KVL. So here Vn, so again plus to minus, let's assume plus to minus, so plus Vn, this is plus to minus, so plus to minus, so Vc1, then again minus to plus, so minus Vc2, that's all, okay, is equal to 0. So this is Vn, Vc1 we already know, Vn. Let's bring this capacitor this side, so Vc2 equal to 2 of Vc1. For negative off cycle, power transformer, capacitor, diode, capacitor and diode. Now negative off cycle is applied, so this will become minus and this will become plus. So when minus, that is negative signal, is applied to diode D1, this diode will turn off, and when this negative is applied to cathode of diode D2, and this diode will turn on. So just drawing it again, negative cycle is applied, so this is minus, this is plus, as always this is input voltage, capacitor, So this diode is off, so it will act as an open switch, or you don't have to draw it. Then again capacitor C2, C1, and this diode is on, so it will act as a closed switch. Now let's apply KVL. So plus 2 minus is V in. Let's assume that current direction is in this way. So plus 2 minus is V in, plus 2 minus Vc1, capacitor is minus 2 plus Vc2 is equal to 0. Now Vn put plus Vc1 we already know from before. Here Vc1 is equal to Vn. So Vcn is Vn minus Vc2 equal to 0. Vn plus Vn is 2Vn minus voltage across capacitor 2. So we need to find voltage across this capacitor. So Vc2 equal to 2 input voltage. So now we have found out voltage across capacitor C1 is Vin, and voltage across capacitor 2 is 2Vin. So here if you see, you can take the output across this capacitor, which is equal to 2Vin. And as already discussed, voltage doubler is a circuit which produces the output twice the input, 2Vn. So that's what we have proved here. So output voltage you can take across this capacitor. So V out is equals to voltage across this capacitor equal to 2UVn. So this is voltage doubler. Next is voltage tripler. Voltage tripler. Again power transformer and one AC source, capacitor, diode, capacitor, diode, and capacitor, diode. Okay, so again you need to apply positive signal, negative signal like before. Plus minus, plus minus, plus minus, diode D1, diode D2, diode D3. So first let's apply positive input signal, positive signal. So this will become plus, so this will become plus, this will become minus. Positive is applied to anode, so this will turn on. Positive is applied to cathode, this will turn off. Positive is applied to anode, this has to turn on, but you will be applying a negative signal here. Consider this as X and you will be applying a negative signal, so this will be turning off. So only this diode will turn on. So you can draw this circuit as capacitor closed circuit, capacitor open circuit, capacitor open circuit. You are drawing the circuit because you have capacitor C1, C2, C3. Okay, so positive, negative, these signs are very important here. This is Vn, and here first you will be applying a positive signal. So like before, you need to apply KVL. When you apply KVL, this minus to plus is minus Vn, plus to minus is plus Vc1 is equals to 0. So voltage across capacitor C1 is Vn. So next again you will be applying a negative signal. When negative signal is applied, what happens is that when negative is applied, this becomes negative, this becomes positive, and negative is applied to anode, this will turn off. Negative is applied to cathode, so this will turn on. Negative is applied to anode, so this will turn off. So when this is off, it will act as an open switch. Capacitor, this is turning on, so it will act as a closed switch, and this is turning off, so this will also act as an open switch. Capacitor C1, capacitor C2, capacitor C3, positive, negative, positive, negative, positive, negative. Now you need to apply KVL for this circuit because this is the closed circuit. Plus minus V in. So minus to plus is minus. Oh, sorry, this is negative cycle. So minus plus. So plus to minus is V in, plus to minus VC1, and minus to plus minus VC2 equals to 0. So V in, VC1 is equal to V in, VC2 is equals to 0. So VC2 equal to 2V in. This 2 we have derived it in voltage doubler itself. Voltage doubler itself. So I am again doing it for each closed circuit here also, so that it will be easier for you to understand. So again, this is an AC signal. Yes. So first positive signal you have applied. Next you applied negative signal. Again you will be applying a positive signal. So let's apply a positive signal. So it is like a previous case. Positive signal is applied, this will become plus, this will become minus. When positive is applied to an anode of diode D1, this will turn on. But we will be applying a negative voltage here. Let this be Y. We will be applying a negative voltage here, so this diode will turn off instead of turning on. So next this positive is applied to cathode, so this will not turn on, this will go into off state. Next this positive is applied to diode D3's anode, so this diode will turn on. So this will act as a closed switch, sorry, open switch. Again this will also act as a open switch, this will act as a closed switch. C1, C2, C3, plus minus, plus minus, plus minus. Here input signal V in plus minus V in. So let current direction will be like this. So minus to plus is minus V in, plus to minus, so VC1. Here also plus to minus, so voltage across C3. Here minus to plus, so minus VC2 equals to 0. So minus V in, VC1 we already know, this is V in. VC3 we don't know, VC2 is twice the input. So minus plus VC3 equals to 2V. Here also the voltage across this capacitor is also equal to 2V. But this is voltage tripler, so we need output equal to thrice the input voltage. So what we will do is, we will be taking an output across voltage across C1 and voltage across C3. Voltage across C1 is V in, voltage across capacitor C3 is 2 into V in. So voltage across this will be VC1 plus VC3, that is equals to 3V in. Since the circuit is for voltage tripler, you need an output thrice the input. So what you will do is, you will be taking an output across capacitor C1 and capacitor C3, whose capacitor VC1's output is V in, voltage across capacitor C3 is 2V in. So totally you will get 3V in. Next, let's see about voltage quadrupler. It's the same like before, but you need to consider for second positive off signal also. So voltage quadrupler, power transformer, AC signal, capacitor, diode, capacitor, diode, capacitor, diode, capacitor, diode. Yes, so for voltage quadrupler you need output 4 times the input, so 4 diodes and 4 capacitors. C1, C2, C3, C4, D1, D2, D3, D4, plus minus, plus minus, plus minus. So first you will be applying a positive signal. When you apply positive signal, this will become plus, this will become minus. When positive is applied to anode, this will turn on. When this positive is applied to cathode, this will turn off. This positive is applied to diode D3, this has to turn on, but you will be applying a negative signal, which we have seen here. For voltage tripler also, for first positive off cycle this will turn on, for second positive off cycle only this will turn on. So for first positive signal this will turn on, we will be applying a negative signal here. So this diode D2 will turn on for first negative off signal. So for this is the input signal. For first one, for first off signal, this diode will turn on. For first negative off signal, this diode will turn on. Similarly, for second positive off cycle, this will turn on, D3, and for second negative off signal, D4 will turn on, and this will continue. So you have to use diodes for each positive and negative signal. So here for first positive off cycle, diode D1 will turn on and all other will go into off state. So you can redraw this as capacitor, only this alone will be closed. This will be like open switch, and open switch. C1, C2, C3, C4, plus minus, plus minus, plus minus, plus minus. Here you are applying positive to negative. Here positive signal is applied. So now these are all open, only this is closed circuit. So you will be applying a voltage across this circuit alone. So applying KVL, minus to plus, minus Vin, plus to minus Vc1 equal to 0, Vc1 equal to Vin. This we have derived in previous cases also. I'll be explaining from the start because it will be easier for you. For negative off cycle, what happens for negative off cycle is, as already told, for negative first off cycle D2 will turn on. So capacitor, this will be open circuit. Capacitor, second diode is on, so this will be a closed circuit. Capacitor, rest all will be turning off. So I will be representing it as a open switch. So plus minus C1, plus minus C2, plus minus C3, and plus minus C4. Here you will be applying KVL for this circuit. This is the closed circuit, this is a open circuit, so you can't apply KVL here. We will be applying for this part alone. So negative signal, this will become minus, this will become plus. So plus to minus, plus Vin, plus Vc1. This you will not apply because this is open switch, only through this. So minus to plus is minus, Vc2 equals to 0. So Vc2 equal to 2 into Vc1. Okay, now let's apply second positive off cycle. So when you apply the second positive off cycle, D3 will turn on. So directly I will be drawing it. Capacitor, this is open switch, capacitor, this is open switch capacitor, and only D3 is turning on, so I'll apply a closed circuit here, and this is also open. So you will be applying KVL across this C1 plus minus, C3 plus minus, C2 plus minus, C4 plus minus. Here you are applying a positive cycle, second positive off cycle. This is first positive off cycle, this is second positive off cycle. First positive off cycle you got Vc1 equal to Vin. For first negative off cycle you got Vc2 equal to twice the Vc1, that is double or voltage doubler. Now you will be applying second positive half cycle, so this will be plus, this will be minus input voltage. So minus to plus is minus Vin, plus to minus Vc1, plus to minus Vc3, minus to plus Vc2. So minus Vin plus Vin, we don't know voltage across V3, minus 2 into Vin equals to 0, because Vc2 is twice Vc1. So minus plus, so Vc3 equals to twice Vin. This we have derived earlier for voltage tripler. V out is 3 Vin, that is Vc3 is 2 Vin. So that's what we have found here also. This part we have found out in voltage doubler, and this part we have found out in voltage tripler. Now we will be finding voltage across capacitor C4 in voltage quadrupler. Now applying negative second negative off cycle. So when you apply second negative off cycle, which will turn on? Only diode D4 will turn on. So capacitor, this is open circuit, you don't have to draw it. Capacitor, so again capacitor diode D3, you don't have to draw it. Then only D4 will turn on, so that alone you can mark it as a closed circuit. So here plus 2 minus C1, plus 2 minus C2, plus 2 minus C3, plus 2 minus C4. Current is in this direction. This is negative off cycle, second negative off cycle, so this will become minus, this will become plus Vin. So plus 2 minus Vin, Vc1 is Vin, Vc3 is voltage across capacitor C2 is 2 Vin. Then in this direction, so minus to plus is minus Vc4. Again this is minus Vc2. What is Vc2 is 2 into Vc1. So minus 2 into Vc1 equals to 0. 2 Vn plus 2 Vn minus 2 Vc1. This we shall take this side Vc4. So 4 Vn minus 2 Vc1 is Vn equals to Vc4. So 2 Vn is Vc4. So voltage across capacitor C4 is also equals to 2 Vn. Voltage across capacitor C1 is equal to input voltage. Voltage across capacitor C2 is 2 Vn. Voltage across capacitor C3 is 3 Vn, and voltage across capacitor C4 also 2 Vn. But here this is voltage quadruplet, so you need the output 4 times the input. So what you can do is you can take the output across capacitor C2 and capacitor C4 here. This part you can take it as output. So output here is Vout equals to Vc2 across plus Vc4. Vc is 2 Vn, Vc4 also 2 Vn, so 4 Vn. Yes. So this is how you will be finding out the output voltage for quadruple, tripler or doubler. So for just remember, for first positive half cycle, first diode will turn on. For first negative half cycle, diode D2 will turn on. For second positive half cycle, diode D3 will turn on. For second negative half cycle, D4 will turn on. Again this will continue. So just you can represent it as open and closed switch. If it is a closed circuit, you can apply KVL and find out the voltage across capacitor C1, C2, C3 and C4. So since the output across C3 and C4 is also VC2, you will be taking an output for for quadrupler across VC1 and VC3. Sorry, for just tripler. For tripler, you will be taking an output across these two. For quadrupler, you need 4 times, so you will be taking an output across capacitor C2 and C4. So this is all about voltage multiplier. All you need is to get an output twice, thrice as we need from the given input signal. So thank you. Hope everyone understood. If you like my video or if you have any suggestions, comments, please let me know. Thank you again. Like and subscribe. Thank you.